Diving inside of our asset, we can see that we have one subnet coming in, one input. I'm going to dive up here as well, and you can see as well we have one input. If we wanted to change that, we would just go, I'm going all the way to the bottom to type properties. Let's see if that's viewable or not. Try to move this up so you can see. Nope, still not viewable, but all the way at the very bottom is a thing that says type properties, and that's what I'm clicking here. If we go into input output, you can see what our label is. So why don't we give this a more meaningful label, and we're going to call this geometry to scatter onto or inside of. As well, you can see we have maximum inputs and outputs, or minimum, maximum inputs and outputs. So I want to make sure that we always have something coming in and that we're always having something going out. And for now, we're only going to have this. Perhaps we'll change that later, but I think right now this is good. So clicking accept. You can also see that when I middle click here, that now kind of gives us a guide and tells us exactly what that input is expecting from us. So inside here, what I'm going to do is just give us a quick label so that we can always access this without this gigantic long text here. So I'm going to press tab and type null. And I'm just going to label this in all caps, input geo. And now we'll start putting down some SOPs that allow us to scatter on here. For easier visibility of points, I'm going to change my background color. I'm going to press D, go to background, and choose dark. I'm going to turn off the grid as well, and I want to make sure I'm off of wireframe, just so that I can easily see what's going on. So if I press tab and type the word scatter, that gives us a scatter SOP. I'm just going to connect right in here. And if I enable that, you'll see that what happens is we get a bunch of points randomly distributed on our input object. And right now they're evenly spaced, or pretty close to evenly spaced. And that has to do with this relax iterations. If I disable that, you'll see it does this kind of random dart throwing method in terms of putting points on here. And all that happens in the relax iterations is that we click that on, and it actually looks to see what the nearby points are, as well as the incoming geometry, and tries to spread the points apart. So this makes it take a lot more time, especially when you have, a lot more points. I don't know if this is going to happen in real time, but you should see that this goes a lot slower once you add more points, and you will see a pretty big difference as well. And sometimes you don't want even distribution. You do want something that feels quite random. So let's keep that at 1,000 for now. And before I start populating our asset, let's start building a couple other things in here. So one thing that we know here is that we are going to use this to scatter onto the surface, and we have a few different methods of doing that. So we can just do by density, which is essentially going to give us a total count if we want, or we can turn off that and we get this thing called density scale. And this becomes really interesting because it kind of looks at the surface area of your incoming geometry and scatters points based on kind of a density. So if I put down a transform here before the scatter and I start moving this up and down, you can see that the apparent density of the points appears the same. The points aren't getting closer and closer together. So this is kind of interesting if you want to keep an apparent density of points while changing the incoming geometry, as opposed to, forcing a total count, for instance, which if I were to do that, you'll see that the points now become more and more spread apart. And our total point count remains consistent though. So let's delete the transform. We'll just keep total count here for now. There's a couple other things you can do in terms of counts per primitive and texture space, etc. For now, we're just going to do this, but you can always check the help card and continue to populate the asset as much as you want. We can use a density attribute as well. So I'm going to turn that on, and you notice it's looking for an attribute called density, and we're getting an error here. So you can see that we get these red lines. If I middle click here, you'll see invalid point density attribute specified. It's basically telling us there is no attribute called density. So one interesting thing here is that I can do something like, I'll just do an attribute create. We're not going to do anything complicated yet. And I'm going to call this attribute density. And why don't we say, I'm going to put an if-then statement in here. So the way if-then statements work is I can say if, and then a parenthesis, and then the statement. So I'll say attribute p.x is greater than 0, and then end that statement. Excuse me, that's the, there we go, that's the condition. And then comma, so if that's true, I want 1, and then if that's false, 0. Excuse me. And now if I turn the scatter on, you can see that where our value is 1, we get a full scatter, and where it's 0, we get no scatter. So you can use things like image maps and textures as long as you're writing to that density attribute, and use that to control how stuff is getting scattered on here by simply deciding that this is the attribute you want to use to scatter your points. So let's turn that off for now. Max points you can use to clip the total number of points. So sometimes if you're using a density scale here, you want to make sure that you don't go over a certain amount of points. And then of course seed changes our random seed value. Relax iterations we've kind of gone through, and of course you can up this if you want more or less relaxation. 10 is generally good. Sometimes I end up going to 50 if I really need it to be quite right. And then of course you can choose the radii that it's looking at with these points in terms of how that relaxation works. Output attributes, output some stuff here in terms of the primitive that it's been scattered on, and these can be really helpful for other things later on that you might want. We'll end up using this in a second, but we're not going to do this right now. Okay, so I'm going to put a null here, and I'm going to call this scatter on surface. Now we'll put down a switch and just wire that into here. Because ultimately what we're going to want is the user to choose whether they want to scatter on the surface or scatter inside the volume or choose some other method of scattering. So right now I'm starting to build these methods in here that we'll end up promoting into our tool. So I can put a null down here as well. And I can call this scatter in volume. Just going to wire that into the second input of our switch. And currently we have nothing going on, or nothing going into our scatter in volume. So there's a few different ways we can do scattering inside of a volume. We can turn our geometry into a volume and then use a scatter SOP and just scatter points inside there. That gives us a fairly irregular shape. We can also do something which is called a points from volume, which I'm going to put down now. So there's a SOP here called points from volume. And I'm just going to wire this right in here and go right into our scatter and volume, and we'll turn this on. And you can see now that what we get is this pretty organized grid of points, which is placed inside the volume of our object. And here you can choose different types of configurations, as well as what the point separation is. We have some ISO value stuff, which I'll kind of explain in a second, but essentially what's going on here is your object is being converted into a volume, and that volume is essentially each voxel of the volume is getting points scattered inside it. It just determines where the surface is of that volume. Then we have jitter seeds, which right now this isn't doing anything because I don't have any jitter scale. So there you can see our seed is doing something here. And you can see what our scale is doing as we jitter more and more and more. But we can just put that at 1 for default. You can offset how the grid works inside. And then there are a few other things you can do here as well. Again, there's relaxations and stuff like that. Some of these things here, I'm not going to promote all of these parameters in this lesson. If you're so inclined, you can promote this entire SOP to your asset level. So it's kind of up to you. But I'm going to put down another way of doing this here as well, which would be to do a VDB. So I'm going to choose VDB from polygons. I'm just going to wire this right into here. And if we turn that on, you can see that we get this ISO surface. And what this is this is a kind of solid representation, volume representation of the surface of our object. But we can't really scatter inside here because this only gives us the surface. It doesn't give us the interior. For the interior, we want a fog. So what we've done is we've converted our object into a fog VDB, and I'm going to choose to fill the interior of that as well. So the voxel size here is what controls the resolution of the volume. So you notice as I dial it up, we can see less and less resolution. I'm going to keep that at 0.1 for now. And that's about all we need. So we've converted that into a volume. Now we can just copy and paste that scatter. And if I turn this on, you'll see that we get a somewhat different kind of scattering. Now notice this is quite a bit slower. Actually, I think it's because we have relaxation on. So it is a bit slower than the other methods, but you can see that you get something that looks a little bit different than that. It just has a kind of different distribution. So this is distributed based on the density of your surface. So you notice as you get more and more dense, more and more density built up in your volume, you get more and more points. And as you have less density in your volume, you have less points. Whereas what this does is converts into a volume, then creates a regular grid. Let's dial the scale down. Creates a regular grid from that volume and then randomizes the points after the fact. So we have two different volumetric scattering methods in here. So I'm going to put down a switch here. And we'll put down a null. And I'm going to call this volume scatter. Except I should spell that correctly. I'm just going to place another null here. And I'm going to call that volume grid scatter. We'll wire volume scatter into our switch, grid into here, and then that into there. So this, I'm going to call this switch volume scatter type. And down here, I'm going to call this switch surface or volume scatter. So you can see our switches are set up right now to change our methods. And these things will be exposed as parameters into our scatter tool. So for now, let's save our asset. So we're going to choose save node type. I'm going to save the file here, and then we'll continue on.